come to the class and share your camera, and whoever wants, you can just share your screen with us, and I can help you to set up the lab environment also. How about the others, guys? Brilliant. Okay. So, who wants to be? Is there any volunteer here to set up the lab environment for you? Anyone? Anyone want to be a victim? Who's that?
Give support for lab setup.
Yeah. We just want to do the lab setup. Are ready for it? Anyone here? Okay, so in case, I'm going to start the beginning of the class. Okay, so this session will be the beginning of the class, and I'm going to teach. I'm going to start from the beginning of the, the CCNP layer 2 topics. Okay, so this is going to be very, very core concept. So this is a core concept of the entire class, and this is very good to understand. But before I go further, I just prepare you a blueprint, as I told you. Let me just show it to you. Here we go. So this is a blueprint of CCNP on core class. So there is a blueprint. It's out there in the internet. I did manage to find out. So let me just share it with you, first of all. Okay, guys, I hope that you can see the blueprint. Can you see my screen?
Yes.
Right. Okay. So these are the topics, all different parts in this class that we are going to do. This is pretty old. It's for 1 year ago. The latest version, which is 1.2, I do not have access to the blueprint, but this one's still here. So you have access. I'm going to prepare you this blueprint. I'm going to share it with you in the Encore group. So basically, I will give you an introduction about them and a different part. So what are them? Basically, some of them are analyze, explain, describe, compare, differentiate, configure, and verify. I do give you this blueprint, and you can have access to all of these topics, starting from the layer 2 technologies. So we do have a layer 2 technology such as the .1Q, the VLANing, the interchannel, the spanning tree protocol, and also I do give you an explanation about the layer 3 topics and some other topics as well. Okay, so this is basically a good blueprint, and you can have a very good overview of the entire class, what different part of this class, and what do you have access to this one in this class, what are them for configuration, and what of them are in general in theory. And also we do have some of the parts for the NRC as well, but this is basically a very good part that you can have access to. Right, okay, so I'm going to share it with you in this class. Let me just share my whiteboard with you. Hope this time works. I just tried for a couple of times to bring up my whiteboard. All right. Gaurav, are you there?
Yeah, hi guys. Good evening.
Hello.
Where will we get this? When will we get this Excel sheet? When the list?
So I just want to ask Gaurav. Honestly, I don't know what is the setup of the WhatsApp group. If Gaurav can help me, Gaurav, can you hear me? Hello, Gaurav. I guess the WhatsApp group will be up in the next couple of hours. Okay.
Yes,
So
yes, correct. I'm sharing a WhatsApp link in a couple of seconds.
Oh, okay, in a couple of seconds.
Yeah.
So Gaurav, for some reason, I cannot just join to the class from. Okay, now it's working.
Okay.
All right, now it's working. Alrighty. Okay, so guys, let's just start the class officially. Let's start the explanation of the basic explanation of the Ethernet protocol. So this is the beginning of the class, and we would like to go through the basic concept of a layer 2 technologies. Okay, so let's first of all let's a little bit about the talk about the packet forwarding, how the packet is working in the layer 2 forwarding. First of all, let's start with the layer 2 forwarding, a little bit talk about the MAC addresses and how that works, and then we're going to continue with some other topics as well. Okay, so I guess you're already familiar with the packet forwarding, how the packet is forwarded through the network. I guess you're already familiar with the layer 2 and layers, basically different layers inside the network. Can you see my whiteboard, guys? Let me just write down something. Do you see my whiteboard? I guess you do.
Yeah, we do.
Brilliant. So first of all, we just want to talk, as I told you, we just want to talk about the layer 2 forwarding, one of them, and how that works. So according to the OSI layer, we're already familiar with the data link. I guess all of you, you're already familiar with the data link. Data link basically is handle the addressing. There's a layer 2 beneath the network layer, and beneath the IP protocol, right? So if you want to forward the traffic between different hosts in a layer 2 environment that we're going to talk a lot in this course, so these packets and these frames basically will be forwarded. The last layer is going to be the layer 2. So this layer 2 is going to have an address in order to forward the packet between the source and the destination inside the segment. Okay, and this is basically a part of Ethernet address. Okay, and this is called MAC address. MAC stands for the media access control, and this MAC is going to have an access for itself. Okay, and I guess you're already familiar with the MAC address. MAC address is it's coming from a long ancient history as an address. 48 bits address, split into 2 different parts. Okay, let me just write it down for you. For example, let's say we do have a MAC address 1, 2, 3, 4, 5, 6, 7, 8, 9A, B, C, right? So let's say if you do have a MAC address, this MAC address has a 12 digit, okay? Each digit, the entire address is 48 bits address. I guess you're already familiar with that. And every address is in a hexadecimal format, in a hex format. And the hexadecimal format means it's starting from 0 to F, right? So let's say the first number is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the first octet, the first 6 digits here, is representing a device manufacturer. Okay, this is a known organization that is just, you know, making the device. Okay, and this is somehow called OUI, or organizationally unique identifier. And these part of the MAC address is going to identify who built this, you know, piece of product. Okay, and basically this part of the address is responsible to make sure this part is always unique in the entire world, hopefully, right? Then the second part of the address is going to be assigned by the vendor. Okay, so the second part, the next 6 digit, is going to be a vendor assigned. And guys, there will be a separator also on these between these numbers and digits. Okay, so you can have a separator. In some platform they just use dots. In some platform they prefer to have column. In some they prefer to have dash. Okay, so there are some different rules in different platform and products. But I do believe the best one, the Cisco basically used the dot format. Okay, in some of them maybe you will see, for example, column, right? Every 2 digits will be separated with a column. Okay, this is a separator. And you know, when a device wants to talk in the network, basically the device is just any kind of host that they just want to start to sending a frame or a packet inside the network. It just start to send the packet to the destination MAC address. And the destination MAC address could be 3 types. Basically, we do have 3 types of a destination MAC address. And this is basically how you can just forward the traffic as well. Different type of a MAC address. Basically, we do have a Unicast MAC address, the Multicast MAC address, and you have a broadcast MAC address. Okay, right? So what is a Unicast MAC address? Basically, Unicast MAC address is a MAC address that is assigned to node, and hopefully when those devices, when they just want to send the traffic to these MAC address, the traffic will be unicast. And the unicast means the traffic is coming from one node to another node, right? The multicast, however, is you just sending from a node to multiple devices, okay, at the same time. So basically, you're just sending one traffic to the multiple devices, not all of them. All right, but the broadcast, however, is when you're just sending a traffic to everybody else in the network. Okay, so you're just sending a traffic to everyone, and this is called the broadcast. We have some reserved MAC address, which is called F, all to it 12-digit F. So we have this MAC address, which is reserved for the broadcast purpose, right? So we have this MAC address as a broadcast MAC address. And when you just want to forward the traffic, or better to say, when you just want to flood the traffic from a node to everyone within a same broadcast domain, basically you're going to use this address, okay? And the concept of flooding is a little bit different between the, broadcast, okay? So we do have 2 different concepts all come together, okay? Either the broadcast and also the flooding, okay? I'm going to let you know in a couple of minutes. So this is a framing and addressing. As I told you, the MAC address is a part of layer 2 addressing, okay? It has been, assigned by the vendor as well as the OUI also, right? And these are different type of the addresses, okay? These unicast, broadcast, and multicast, these are fancy terms that represent, nodes in a segment. Either they can represent a node, one single node in a segment, or a couple of nodes in a segment, or all nodes within the same segment, okay? So unicast basically is a term that you're going to use to send a traffic to one single node. But you know how these nodes can differentiate whether this MAC address belongs to the single node or a couple of other nodes by looking at something very special, right? Every MAC address has, as I told you, 6 different bytes, okay, or 48 bits. consisting of the first 3 bytes by the OUI and the next 3 bytes, the last 3 bytes basically by the vendor assigned. Okay. From the first byte is one of the most important bytes of the MAC address because it can represent 2 very important vital bits to the network equipment. The first one is an IG bit, and the second one is UL, right? So there is 2 very special bits in a MAC address. The first one is IG, and the next one is UL. What is this basically IG? The IG is 7th bit of the MAC address from the most significant byte, okay, which is the first byte, and the least significant bit, right? So, okay, for example, here, 1, 2 here, this is an hexadecimal digit. So if I want to write them in a binary, okay, here we go. We do have 8 bits here. This bit, okay, and this bit, these are 2 important bits. So the 7th bit is called UL, and the 8th bit is called IG. Right? So what is this UL? The UL stands for universal or local, and the IG stands for individual or group. So when this IG bit is 0, it means that this address is unicast. But when the binary is 1, it means that the address is multicast, either multicast or broadcast. Okay. However, the UL, okay, the 7th bit of the MAC address, the binary 0 means this address is assigned by the vendor. Okay, it hasn't been modified by any administrator or a network engineer or by Guy or by other software inside the network. If you do modify the MAC address of a node, then this bit should be 1. But if the MAC address is assigned by the vendor, so this bit should be 0, right? So if you look at this MAC address that I wrote so far, 1, 2, for example, if I want to write it down, so this is 1, and this is 2. So basically, if you look at here, you see this is the Unicast MAC address. And why is that so? Because the IG bits is 0, right? And if the 7th bit is 1, okay, it means that this MAC address has been assigned by the administrator. Okay, it's an administratively assigned. The vendor assigned MAC address has been override by a software or by someone, right? Okay, so the IG bit signifies whether the address represents an individual device or it represents a group of devices. Okay, so if it is 1 and it is the address, it is not all F, it means that this is the multicast MAC address, right? And if it is all F, okay, then this 8th bit will be 1, and the entire address is FFFF. Then it represents the broadcast traffic, the broadcast term, right? Guys, are you all there? Is there any questions so far? Okay.
No.
So you all good? Can you hear me?
Yeah, we're okay.
Okay, I hope, is there any question? Do you have any problem with my explanation? Do you feel comfortable about all of these topics so far?
Yes.
Yeah.
No questions.
No
Same
problem?
with me.
So
No.
you mean for the IG, if it is 0, is unicast. If it is 1, is multicast, right?
Either multicast or broadcast.
Okay.
But the broadcast needs to be FFF. So if the address is, for example, let's say if the address is 13 here, okay? So it means that this bit is 1. So in this case, because the destination MAC address is not all F, right? But the IG bit is 1, so it means this is the multicast MAC address.
Okay.
You get me?
Yeah, I do.
Okay. Any other question?
Does it happen that the UL get any other value other than 1 or 0?
No. Basically, this is because this is a bits and binaries. It could be either 0 or 1. There's no other number.
Okay. Okay. Why I'm saying that maybe this is something like in the medical field. Sometimes we may be facing devices where people, like the vendor has to rewrite the MAC address. It happened. So in that case, then we cannot know how many times like that same machine get different MAC address.
Yeah. Correct. Okay. So yeah, unfortunately, there's no way that you can understand. This basically, this is the rule. You can either assign a MAC address with the by yourself, which it has the last the UL bit with a 0 value. Okay, but this is how it works. This is a written rule for everybody in the world that they can realize that either this is the vendor assigned MAC address or this is the administratively assigned MAC address. Okay, and these are going to help you to find out these kind of addresses. Okay. So for the next part, we're going to talk also about the switching and the bridging logic. Okay, so a switch basically, it has a responsibility and very ultimate responsibility, which is going to deliver the frames, okay, the frames to the appropriate destination based on the MAC address, which is coming from the header of the frame. Okay, so when a switch, okay, imagine you have a Kali switch. We're going to talk about these switch and bridge terminologies later on in this course a lot. But let's say when a switch receives a frame, the first responsibility of the switch is to find out the destination MAC address out of the incoming frame header, and then just follow the logic, okay? And the logic of these forwarding frame could be differ based on the type of destination MAC address, right? So we have, as I told you, we have 3 different parts so far, 3 different behavior of the LAN switch devices. Either it can forward in a unicast way, broadcast, or multicast. However, the unicast itself has 2 different ways in order to forward the packet, okay? For the unicast forwarding, because it looks like this is the most efficient way to forward the packet, the switch, the switch needs to know about all of the unicast addresses, addresses in the network. Imagine if this switch is connected to thousands of devices here, okay? So maybe, let's say we have a 48-port switch, okay? And this switch is connected to other switches as well, either upstream or downstream. And those switches, they're also connected to some other devices in the network as well. So we're talking about the hundreds of ports or thousands of ports. I don't know, okay? So imagine if you're just expanding these layer 2 criteria, these layer 2 ecosystem inside the network. So the switch needs to learn all of those MAC address in order to forward the packet to this correct destination, okay? Imagine, let's say, for example, one client here with a MAC address of 1111101, and it just wants to forward the packet to one single MAC address, for example, 22222. So and let's say you're just forwarding a frame, and this is the frame with the destination MAC address, and with the source MAC address and the destination MAC address. The destination MAC address is 2222, and the source MAC address is 1111. So all 1. If the packet arrives on a switch, okay, according to the unicast, switch needs to forward the traffic in a unicast way. It needs to forward the packet to the correct destination port, right? But sometimes the switch doesn't know about the destination. And this is a confusion part about the unicast. And in a unicast, we have 2 different types of unicast. either known unicast or unknown unicast. We do have two different types of unicast, either known or unknown. Okay, what are them? The unicast, a known unicast, is happen when the frames is forwarded out the single interface, which is associated with the destination address. Okay, so what I'm telling you so far is the basic behavior of the switch. You know, when the switch receives a frame from the from a host, okay, or from an intermediate device, what the switch does, it is creating a MAC address table for itself, okay, because it wants to have a record of all those connected links and nodes and hosts inside the network. So the switch is going to collect those information, okay, it's going to write down, this is, for example, interface, and this is the MAC address, okay. When the switch receives a frame, it's going to look at the source MAC address. Okay, so it says, for example, on my interface Ethernet 0/1, I do see a MAC address, which is 1111. It just keeps tracking of all of those MAC addresses that is connected to its port. Okay, and when the traffic arrives on a switch port that is destined for one of those MAC addresses, what the switch does, it's going to simply forward the frame out of the single interface associated with that destination MAC address, okay? And this is how the known unicast works. However, the unknown unicast is a way that the switch doesn't know where is the location of the unicast address. So in this case, the switch receives a frame which is destined for a unicast address, okay? But the switch doesn't have any clue about the destination location of the destination MAC address location. So the switch doesn't know anything about that. And you know what the switch does? It's going to forward the frame out of all interfaces in the same broadcast domain. Do you get me? So in this case, we call that unknown unicast. The unknown unicast is the way the flooding of frame out all interfaces, except the one that is just received the frame. And this is called the unknown unicast. The broadcast, as I told you, is simply the same thing. It looks like the flood the frame, and the broadcast and unknown unicast, they are both identical, okay? Besides, the unknown unicast, the destination MAC address is unicast, but the broadcast, the destination MAC address is all F. And the multicast is just forwarding a frame. It looks like the unknown unicast or the broadcast, but it has a difference also. We're going to talk about the multicast traffic forwarding in the future of this class. We have a very interesting part in this class that we're going to talk about the multicast way to forward the traffic, okay? So for the beginning of this class, let me just show you something that will be very interesting to see for all of you. Let me share my screen with you. And you can see the switches. Here we go.
Is it acceptable to use the term flooding on unknown unicast?
Absolutely. Yes.
Broadcast. Okay, right.
No, not for multicast. In the multicast, you're not flooding the traffic. Basically, if I want to give you an introduction, a very quick introduction, it's going to be, in the multicast, there are some people, they're just joining to the group, okay? Not everybody. Imagine you have a VLAN and a network consisting of, let's say, 40 nodes in the same VLAN. They're all joined in the same broadcast domain. They're supposed to, receive the traffic, all of those flooding traffic. But let's say a couple of them, maybe 4 of those clients, they're just joining to the group multicast, okay? and then they wish to receive, let's say, for example, a video traffic in the future. So in this case, they're going to join into that specific group address. And in the future, any packet that is destined for that particular MAC address is going to be delivered to all of those 4 ports. Not everybody else. But you know, the flooding term, basically in the flooding term, we're just using most of the time for the broadcast and the unknown unicast. You know why? Because you're just sending the traffic out of all interfaces. But you know, for the multicast terminology, you're just sending for 4 ports. There is some rare case scenarios in the multicast that you're going to flood the traffic out of all ports. I'm not going to talk about that right here, but in the multicast part, I will tell you what is these case scenarios as well.
Yeah,
okay.
Why I was thinking about that, because I was saying that since it's a group that you're gonna have to send the traffic, so I'm going to float the traffic to that group. That's why, you know, I understood it, but it's clear enough.
All right. Okay, so guys, this is a scenario that we are going to talk about that in this class later on, not now, but let me just show you something for the beginning. Here we go. So I just want to show you the MAC address table, right? What is this MAC address table? Every switch is going to have a MAC address table assigned, okay? And this is the output of the MAC address table. And it, you know, it shows you those MAC addresses that is connected to, for example, every one of those ports. For example, Ethernet 0/1, Ethernet 0/0. So in a real world, you're going to see a little bit different naming convention, but here I'm just using this one as well. So let's say, for example, on the VLAN 10, you do have a MAC address AABBCC 000301. Okay, this is a dynamic MAC address and it's connected to the Ethernet 0/0. Okay, for the VLAN 20, 21, and the other ports, I just received some other, MAC address as well. So simply, this MAC address table is going to show you the content addressable memory of each and individual switch. It's just representing those information to the switch. And when the switch receives a frame, it's going to look at these MAC address table. And these MAC address table is also going to have an aging time as well. If you want to see the aging time, you can just also use the show MAC address table, the aging time. It just shows you the global aging time for this MAC address table. So whenever a packet or a frame receives by the switch is going to take out the source address, put it inside the MAC address table for 300 seconds. And whenever the traffic is received again, this timer will be renewed again for again and again and again until the timer is expired. Okay. And also, if you want to find out about any of those addresses, for example, for this specific MAC address, you can also look at here. I guess it's supposed to show you, I need to write down something else, address. Yeah, okay. So for example, if you're looking for a specific MAC address, you can just type the show MAC address table address followed by the MAC address, and it just shows you that, okay, this MAC address is connected to the VLAN 10, and the MAC address, this is the type is dynamic, and it's connected to the Ethernet 0/0 port. So in case, if you're looking for a specific MAC address, you can just look for it inside the MAC address table. Okay, so this is the basic traffic forwarding by the switch, right? This is how the switch basically behaves in the in its port, okay, when it receives the traffic. All right, and this is an Ethernet LAN segment. So for the next part, I would like to talk to you about the broadcast domain. As you know, in an Ethernet LAN, there are so many devices connected to maybe a switchboard or a couple of other switches as well. So they are all part of the same domain, okay? So those devices that receives a broadcast sent by someone else in the network, this is called a broadcast domain. That criteria of those groups is called a broadcast domain. So the broadcast domain is the switches that they're sharing these broadcast messages with each other. On a switch that have no concept of a virtual LAN, okay, a switch simply forward all broadcasts out of all interfaces, okay? Let's say you didn't configure any VLAN on that switch, and those ports, all of those ports on that switch, they all belong to the same VLAN 1, okay? And as a result, all interface, but they belong to the same broadcast domain. As a matter of fact, when the switch receives the broadcast message, it's going to forward it out on all of those interfaces except the port that receives the same traffic, okay? So this is how it works. But the VLAN is one of the simplest concepts of network, for the isolation of the traffic, for controlling the broadcast. This is how you can just do the segmentation. This is one of the most, let's say, one of the it's not advanced, let's say it's one of the simplest way to just do the segmentation. That you can just do it by yourself is one of the administratively defined, the subset of switchboard that they are in the same broadcast domain. So you can just group those ports into the different VLANs based on, let's say, sometimes you can just separate them based on their functionalities, based on their location. So they have a couple of different let's say reasons that you can just group them in the different groups, for the future expansion, right? But one of the most important one of them is the functionality of those ports. Okay, by creating the multiple VLANs, the switch, they are going to create multiple broadcast domain. By doing this, a broadcast, when the broadcast sent by a device, then it's going to be forwarded only to those nodes or devices that they are just living in the same VLAN, right? So the VLAN concept is the concept that you're just using to, identify those nodes with the same functionalities, and also they're just supposed to receive the same broadcast, okay? And when you are just configuring the VLAN, also you need to assign a specific IP subnet as well. Keep in mind, there is a one-to-one relationship between the IP and the IP subnet and a VLAN numbers, okay? So basically, when you're just assigning a VLAN numbers, you need to assign a separate IP subnet mask as well, okay? Simply put, the devices in a single VLAN, they are typically also, they need to be in the same subnet, okay? So would it be, sometimes it, people just asking me, 𝐍𝐤, what's gonna happen if I just put multiple subnet in the same VLAN? Would it be possible to do this? Yes, it would be, it is possible to assign multiple subnet, but it is not recommended, okay? I don't understand what is, what is the reason behind this. Most of the time, because all of those nodes, they're just sharing the same broadcast domain. And honestly, it would be much better to use the single IP subnet within the same VLAN. But as a CCNP candidate, I don't see any reason to not assign those multiple subnets as well. You can just do it if you need it, okay? Okay, so let's talk a little bit about the VLAN configuration. How many VLAN do we have inside the network? Basically, in every switch, you can assign up to 4,096 different VLAN, right? So the VLAN is, you can identify a VLAN ID for each VLAN. It has an identity starting from 0 to 4,095. Basically, it's a 12-bit for the VLAN number. And each VLAN can have a number, okay? Can have an identity, and also it can have a name as well, okay? Basically, on every switch, when you're just log into one of those switches, you can just create, modify, delete those VLAN. But if you want to have access to them, you can just use the show VLAN bridge to see the range of those VLAN. For example, here I do have VLAN 10, 20, 21, 22. Okay, so you can just log into those devices and do modification of those VLANs. Okay, and every switch for doing this, this is have a basic machine, right, for managing these, VLAN information, which is called the VLAN database. Okay, the VLAN database is a database which is consisting of all of those layer 2 configuration. Most of the time, it is consisting of VLAN configuration. This configuration is consisting of so many other devices. Okay, and even if you are working in the routing platform, sometimes people asking me about, what if I do have a router? Can I have, the VLAN configuration as well? Yes, you do, right? But you cannot assign the VLAN to the layer 3 interfaces. You need to buy those layer 2 interfaces or Ethernet switch module in the on those routing interfaces. So if you have a router, then yes, you can just install those modules on the router, then you can install those interfaces, and then yes, you can just use the VLAN database as well. And the VLAN database has 2 different range, starting from 1 to 1005 and 1006 to 4094. And this is called the normal range and the extended range. So we do have 2 different range that we can use, okay? Either the normal range or the extended. Guys, are you okay out there? Everything okay? Are you enjoying the class? Any questions so far?
We are. Yes, we are.
That's great. Great to hear that. Okay, so any question? All comfortable?
All covered.
That's great. Brilliant. Okay, so where is this VLAN database? The VLAN database is stored in a file, which is the VLAN.dat. In general, the VLAN database configuration is all stored in that file, okay? And, in the different type of platform, you will see maybe different location, but most of the time it is stored in the flash of the device, okay? Right. So let's say when you're just creating that VLAN information, these VLAN information, it's just recorded in a VLAN database. And if you want to modify those entries, you have 2 different ways to modify those VLAN database entries. Either you can just go to the VLAN database here. Sorry, you can go to the VLAN database here, right? Or okay, you can go from here, VLAN database, or you can go from the configuration mode. This is the VLAN database. Most of the time, you can have access to the VLAN database configuration mode from the switching and routing platform. But, I've never seen someone that has a switch that using these VLAN database mode. But most of the time, I do see some, network engineer, they just use the VLAN database mode on the routing platform. Because in the routing platform, you do not have those configuration mode as well. So let me just go to the VLAN database, go to the configuration mode, right? Here, you can just create the VLAN or you can modify the VLAN from here, okay? Right now, because I'm a VTP client on this device, I do not have access to those VLANs. Let me just go back there a little bit here on one of those other devices. Yep. So if I do want to create the VLAN here, for example, VLAN 10, I can create it from the configuration, global configuration mode. So this is the first place that you can just create the VLAN. By creating that, by entering that VLAN 10, then you can just create a new VLAN or enter to the configuration of the previous VLAN. And inside each VLAN, you do have access to many different parameters. You can identify them, right? We're going to talk a lot about them, but for the moment, I would like to give you a general introduction about those VLANs, okay? So here you can just identify, for example, name. Let's assign a name. For example, I just want to say the name of this VLAN is accounting, right? Why not, right? Then if I do exit, then my configuration will be stored on that VLAN. Then later I can just use the show VLAN brief, right? And then this VLAN 10 will be here. This is the VLAN 10. This is the name of my VLAN, which is accounting, and the status of the VLAN is active, right? Make sure that you understand these terminologies. Again, we're going to talk about them as well. What are this active, suspended, Lshot, and no shot? What are them and how they're useful? They're going to be lifesavers sometimes. If you're familiar with these terminologies, they're going to be very, very helpful. Okay. So when you can create these VLAN by doing this, or you can go to the VLAN database as well, right? You can go to the VLAN database here, and you can create the VLAN, for example, VLAN 11, right? Then you see the VLAN 11 has been added to the to the VLAN database. And if I just use the show VLAN brief, I see, okay, it already told me that the VLAN is added to the VLAN database. But when I just use the show VLAN brief, it tells me that no, there's no VLAN configuration in your VLAN database. The reason is that you need to save the configuration or apply the configuration or commit the configuration in there, right? If you use the show current, there's a command here, a couple of commands here, okay? If you use show current, it just shows you the current VLAN database here. And you will see there is no VLAN 11 here. Okay, so my configuration is in, let's say it has not been applied to my device. So if I want to apply my configuration, I can use simply the apply, right? And then if I use the show VLAN brief, and then yes, the name of the VLAN will be, the VLAN will be added to the database. I'm not a fan of these VLAN database things unless I do have a routing platform. So I prefer to use the global configuration in order to control the VLAN database. I would say it's better to control them from over there, right? So if you want to create another VLAN, let's say VLAN 11, if you want to change the VLAN, for example, sales, you can just do it simply, but make sure to exit the VLAN. Before, none of your configuration will be saved until you make an exit from that VLAN configuration, okay? So what if you want to create multiple VLANs at a time, okay? Let's say you just want to create 100 VLANs at single time. So you can just do VLAN 200-300, okay? Then press exit, right? And if you press the show VLAN brief, you will see the range of the VLAN has been created to the switch, right? This is these are different commands and tools in front of you in order to control the VLANs, and you can just create those VLANs. How about if you want to put a single interface or a couple of interfaces into the VLAN? Okay, what should you do? For example, in this case scenario, okay, on a switch B1, for example, I just want to put the interface Ethernet 0/3 into the VLAN 1400. Okay, what should I do? First of all, the VLAN 1400 is the extended range. If I do configure the VLAN 1400 with the name of, for example, the ext sales, for example, this is the extended sales, and I can say do show VLAN brief. And here we go. This is the extended range. This is the VLAN from an extended range. So what if I want to assign this interface to the extended range? What should I do? First of all, I need to go under interface, Ethernet 0/3, right? Then you need to change the switchboard mode. Okay, what is switchboard? The switchboard stands for the operation mode of the single interface. When you're telling to the interface that you're a switchboard, it means that this is the layer 2 interface, okay? So this is the switchboard, and the mode is access. The mode of each interface could be either access or trunk. And the access means the port is connected to a single device, and the trunk, it means that it is connected to some of the devices that they're responsible to forward the traffic to the other side of the network, okay? And the trunk can carry multiple VLAN traffic that is coming from some other ports, okay? But when you're just configuring a mode access, you can only assign this access port to one single VLAN. Then I would specify switchboard access VLAN, for example, 1400. Then if I do say, do show VLAN brief pipe section, for example, 1400, okay? It do says, all right, your port 1400 is the name is, for example, ext sales is active, and the Ethernet 0/3 is assigned to that specific VLAN, right? Okay. And you can also see the configuration by doing this as well. Do show run interface E0/3. Okay, and it just shows you your configuration as well. Your configuration is interface Ethernet 0/3 is in the VLAN 1400, and the mode of this switchboard is access, right? Okay, is there any questions so far?
No, sir. No.
Oh, good. Okay, so, all right, that's it. So as I told you, if you want to assign a single interface, for example, if you want to assign interface E0/2, right? If you want to assign the interface E0/2 to another VLAN, but you don't want to create the VLAN before. So if you want to create that VLAN at the same time, and you just want to create the VLAN and assign the port to the VLAN simultaneously, if you want to do it, what should you do? There is a single command. You can just use the switchboard mode access, right? And the switchboard access, for example, VLAN 1401, right? If you just do this command, then the switch is going to assign the port to the VLAN and create the VLAN simultaneously. And later you can just go to the VLAN, for example, VLAN 1401, and then you can just change the VLAN, for example, ext ACC, right? How about that? You can just do such a thing, okay? And you can just also verify your configuration as well. Right? This is how you can control the VLAN inside the network. This is pretty simple, right? There's some other commands here. For example, show VLAN 1400. Okay, so show VLAN, I guess VLAN ID. There's a summary command. Yeah, here. So if you want to see more information, more precise information about this single VLAN, you can just use the show VLAN ID 1400, and it just shows you some of the information. For example, about the MTU of the VLAN, about the VLAN 1400, the MTU is 1500, and some of the information would be here. So if you have span configuration, we're going to talk about the span also. If you have a primary, secondary VLANs as well, it's going to show you that information as well. This is going to be very, very helpful if you want to see all information about the single VLAN, in case if you have plenty of them, if you have hundreds and dozens of those VLANs in every switch, okay? So, you know, the concept of controlling those VLANs is pretty straightforward. I do want to show you something else as well for those VLANs, which is going to be very, very helpful for you if you want to control the traffic inside the VLAN. Imagine in one very good day of your work, someone is coming to you and is going to say, hey, for example, hey, 𝐍𝐤𝐬, we do have a problem back there. We do see a ransomware in the network. It's just propagating himself to the VLAN, also to the other VLANs of the network. We do have only one victim here, but we don't know how many others, computers have been infected by these ransomware. So the best way to control the traffic inside the VLAN, to shut down them all inside the VLAN, but you don't know how many of them is out there, do you? Let's say if you have a 48 ports, if you want to shut down all of those ports at the same time, it's going to be a long journey. There is a single command for you. Let's say, for example, VLAN 10. If you want to shut down that VLAN, there is a command here. This is called shutdown. The shutdown command, okay, at the VLAN level is going to help you to turn off all those ports inside the VLAN, turn them off, at the same time without any other effect on the other, VLAN. So all of the port members inside the same VLAN, they cannot send any traffic to the rest of the network or to each other inside the same VLAN. So if you see the VLAN 10, it just shows you that the VLAN 10 accounting currently is Lshot. And the Lshot stands for the locally shut down, okay? But the Lshot means it's going to only shut down the VLAN on its one single switch, right? If you do have a BTP configuration in the network, okay, if you do have VTP configuration in the network, then there is another command, there is an alternative for you here, okay, VLAN number 10, you can just use the state suspend, right? And the state suspend is going to take down all of those ports in every switch and all VTP members at the same time without any other impact, okay? So it's going to take them down. So let's say if you have an infected VLAN, and you just want to make sure all of those port members inside the same VLAN, they're not going to forward any traffic to each other or anywhere else in the network. This command, the state suspend, is going to help you to control the traffic in the, let's say, in a network wide, okay? But the shutdown command is only for the locally switch. It's a locally significant command versus the network significant command, right? So if I go back to the show VLAN brief, it says this VLAN is suspended from the rest of the network, and also it is the Lshot. But the suspend, it's only impact on the VTP switches, okay? So if you do not have VTP configuration in any switches, then this suspend doesn't have any impact on the other switches as well. So the shutdown is for locally, and the suspend is for the network wide. Okay, so as a summary, the VLAN creation is a process. But this is simple, but it could be problematic in a large-scale network environment. If you do have many VLAN exist, if you do have multiple switches, if you do have, let's say, dozens of switches and ports all around the network, okay? So if you want to control them, instead of, do the manual configuration on each switch, sometimes you just want to use a way to automate and control the VLAN creation inside the network. And this is called VTP. The VTP, or VLAN trunking protocol, is the way that you can just simply use in order to create VLAN once in a single switch and propagate these VLAN database to the rest of the network. Imagine if you have 1,000 different VLANs, you don't need to create those VLANs again and again and again, okay? So create them once and use them many, all right? In many different platforms. You do not need to create the VLAN database over and over again, okay? All good?
All good, Kaveri.
Brilliant. Okay. But before we go deep into the VTP, I would like also to talk about the interswitch links. If you connect two devices between each other, if you connect two devices to each other, so what's going to happen to these links between the switches? These are called interswitch links. Those interswitch links, they can have two different protocols, either the 802.1q or ISL. So ISL is an outdated protocol. Now we don't use them anymore, but it supports the normal and extended range. It has been created by Cisco, so sad. It's going to encapsulate the packet, and it doesn't support the native VLAN as well. However, the .1q is a very light protocol that that can be used in order to forward the frame between the switches on interswitch links. Okay, let's say we do have a switch here, and this switch is connected to another switch. There's one client here and one single client here. They both of these clients, they are connected to a port which is VLAN 10 assigned. okay? And there are two more clients here on VLAN 20. And if you want to forward the traffic between these two switches on an interswitch link, let's link between these two switches. It should be either on a VLAN 10 or VLAN 20, right? But now I want to forward these traffic on both of those VLAN at the same time. Okay, so in this case, you can just use the concept of .1Q. Why? Because .1Q is going to insert. This is going to be a trunk link. And this is a .1Q protocol. And the .1Q protocol can insert a 4-byte header to each of those frames. And this is called tag, right? Simply, it means a tag into the original frame, okay? And this original frame, the other part of the frame, they just left without any, the switch does not touch those parts, only insert that tags. And normally, those Ethernet frame, they're consisting of the source addresses and the destination MAC addresses. The only difference is the frame tagging in the middle. So that's why it's basically pretty light, okay, compared to the ISL, because the ISL is going to encapsulate and create new packets. But you know, the .1Q, however, is going to just put a tag in between. And this 4-byte tag is consisting of a VLAN, right? VLAN ID. There is a priority field here. There is a priority field here, and very small part here. Okay, so this is called the .1Q. You know what .1Q does? What the .1Q does? The .1Q just uses these tags in order to forward the frame to the other side of the network. So imagine when the traffic is received on the switch port of the VLAN 10, when the traffic arrives on the .1Q port. So the switch is going to tag the frame that this traffic belongs to the VLAN 10. And when the packet arrives on the other part of the network, the switch is going to inspect on the layer 2 frame header. It's going to say, all right, I see a tag, and the tag says this traffic, this frame is belong to the VLAN 10. So what I will do, I just forward it to the VLAN 10. Okay, I'm looking at my MAC address table. I do find the destination port. Then I simply forward the traffic to all ports inside the inside the same broadcast domain. If it's flooding traffic, for example, the broadcast traffic or the multicast traffic or some other type of the traffic, I'm going to forward it into the network, right? So that's it, okay? This is how trunking works in a very quick way of introduction of those trunk ports, okay? So the trunk ports basically can carry multiple VLANs. The trunk port, very good way to forward the traffic between different switches when you have different type of ports. And also you can just use the trunk ports between the switches and also the routers, the firewalls, if you want to just forward the traffic coming from multiple VLANs and forward it to the single port on the other side of the network. You know, upon the receipt of these frames, the remote site, okay, the remote device, for example, the switches or the routers or the firewall, they could just open it up, look inside the packet header to the .1Q header, remove that .1Q header and forward the traffic to the respective VLANs, okay? So guys, when you're looking at the trunk, it just looked like something. This is an introduction to something. This is a basic level of virtualization, okay? So, you can just do this virtualization in here. So let's say if you have a server on the other side of the network, how about that? So if you just connect this switch to a server, okay? And this server, however, has an hypervisor, okay? So, or let's say it has an operating system with a trunk capability, okay? So, or these switches can have a virtual switches inside, okay? Some V switches, either DV switches, the Nexus 1000V, or V switches, standard V switches. If it has a virtual switch, so the servers can also receive the traffic from multiple virtual machines, okay, on a VLAN 10, and forward it with a tag onto the network, okay? So trunk you can just use the trunk link between the servers also, between the virtualization, between the hypervisors as well. I'm not quite sure if you're familiar with the hypervisor, but if you're not, don't worry, we're going to talk about the hypervisor in this class. Very, very introduction level as well, okay? So how about that native VLAN, okay? Before I go to that native VLAN, is there any question, guys? Because this is the first session, basically, this is the first official session of this class. Do you have any question? Do you have any problem so far? Everything okay? Guys, don't worry. If you want to ask a question, break the ice. Don't worry. You can just ask the question whenever you want.
Sir, can you please explain the .1q concept again?
So basically, as I told you, the .1q basically is simply tagging a frame when you just want to forward the traffic from VLAN 10 to another switch, which it has a port in the VLAN 10 again. You're simply using the .1q in order to tag the frame. So when the traffic is received on the trunk links, the frame is going to receive a tag in a VLAN 10, and the traffic is forwarded to the other side of the network, and the other side of the network is going to receive the frame, open it up, remove the tag, and forward it to the ports in a respective VLAN. Okay, and this is how .1q works. Any other question?
Yeah. Once the switch 2 receive the frame, and when he send to the host, it will send via unicast packet or broadcast.
Honestly,
the port, right?
It depends. It depends on the MAC address, and it depends on the switching MAC address table. So if it is a known unicast MAC address, meaning that previously switch does have all of those information about the MAC address, okay? Let me give you an example. For example, if the client is forwarding a frame from MAC address 1111 to the 22222, so if the switch knows where is the location of the destination 2222, so simply switch forward the frame in a known unicast way. Okay, this is switch behavior. But if the switch doesn't know about the location of the destination, you know what the switch does? Switch simply forward the frame out of all ports in the same VLAN. Right? Okay. So guys, what's gonna happen? Yep. Hello.
Is there a handshake mechanism which happens over here also, like the way it happens with IP, wherein the host?
Okay. There is a very bad mechanism which is called the dynamic trunking protocol, or DTP. It has been, the DTP is basically, there's a negotiation between those ports, handshaking mechanism to just set up a port with the trunking capabilities. But honestly, this is one of the worst protocol ever, okay? Because, the port either can work as an access port or a trunk port. Let's say this is a very bad situation if you just play with the DTP. Because, the DTP, honestly, is one of the worst protocol ever, okay? It is pretty dangerous. What is the port? The port is connected either to the client or the other switches, okay? So you're familiar with your own network environment. Why should you just put the negotiation protocol? Why do you need that? Because, imagine if these clients, if there's a hacker, so there is always a potential to put that port instead of an access port, to put it as a trunk port, okay? And then these ports can be a problem for you because the port can receive all traffic for any other VLAN from the network, okay? So you don't want to have these mess any time in the network, okay? So please try to disable the DTP feature from all ports inside the network. Make sure to not have these feature on all ports in the network, okay? Remove that. By doing the switchboard no negotiate command, you can deactivate the DTP feature from the rest of the network, from those ports. Okay, guys, that's it for today, right? I just wanted to tell you something about the native VLAN, but just leave it for the next session, for the tomorrow session. So for the tomorrow session, I will give you another introduction about the layer 2 topics as well. I will tell you something about the laboratory as well. We're going to set up the lab, right, all together, and I'm going to give it to you, this lab. Right, let me share the lab with you one more time. Okay, so tomorrow we're working on these lab. Okay, this is going to be our lab for the next couple of sessions. So we're going to talk a lot about these labs for the spanning tree part of the class, for the trunking configuration, for the VTP part, and also for the Ether channel part of this class. We're going to talk a lot about this part of the class. So is there any other question?
How about the setting up of the machine and all? You were supposed to be doing that today. That was expected.
Tomorrow we're going to do this. I guess that we have some, we need to have that WhatsApp group. So because we already have the WhatsApp group right now, we're going to do it on the tomorrow session. So everyone join to the WhatsApp group. I'm just giving you the blueprint and also an Excel sheet. So then tomorrow you can just work on that Excel sheet. I would just update you with the task for the tomorrow session. Make sure to have all of these things. And also, guys, for the tomorrow session, some of you need to share your screen with me, right? Okay?
Yeah, sure.
Right?
Yeah.
Did you join to the WhatsApp group so far?
No, sir.
Yes, sir. Yes, sir.
You already joined.
You already joined. Brilliant.
Yes.
Brilliant. Okay, so then that's it. So I will see you all tomorrow at the same time, and I will update you about your responsibilities and your task and your assignment for the tomorrow session as well. So if there is no kind of question for today's session, again,
I did not receive the WhatsApp group.
it's in a chat box. Can you see the chat box?
I did not get to.
You can just click on the chat, and the chat will be up here for you, and you can just join to the WhatsApp group in there.
I'm not seeing anything.
You see that now?
No.
No, sir.
Okay. So let me just copy it for you again, once again. Here we go. Can you see this now?
Yeah, I see it now.
Right. Okay, brilliant. Any other question? Here we go. So tomorrow I will see you, and we're going to go to the next level. Tomorrow we're going to start to do the configuration of the lab, and also we're going to tell you something more about, I guess tomorrow is going to be a very challenging session, very interesting session. Try to attend from the beginning of the class. So take care of yourself, and I will see you all tomorrow at the same time. See you tomorrow, and goodbye.